Dozier, you turned in homework in pen, and not only in pen, but it was like this. Let me just show you.
You said I could on homework. You said it's not on quizzes.
I was talking about whenever I graded homework yesterday. Do what? I am. All right, give me questions about your homework. Questions? You're gonna have to call out. Somebody just holler one out, and give me the equation. What's the quadratic equation or expression? Okay. So what number is this? 39. 29. So I hollered this out. I don't know if a lot of you heard me at the end of class, but a couple of things about ones like this. And I would put this in your notes section so you make sure you have it. If your leading coefficient, what's a leading coefficient? The first one, the one that's hooked to the x squared. If that is negative, you always want to factor out a negative, even if it doesn't have a GCF. You don't want to factor with a leading coefficient that's negative. Not that you can't, because grouping still works, because grouping always works, but it makes for an ugly problem. So I know I'm going to take a negative out. Is there another GCF here besides just -1? 3, -3. If I take out -3, what's left? 12x squared. Yes. Plus 5. So now what multiplies to 60x squared but adds to -16x? There you go. -10x, -6x. Is everybody with me on that one? So I have this 3 is just going to follow right along. Yeah. Oh, no. Okay, hold on. Back to my factor here. Go ahead and slash. What can I take out of the first two? 2x. What's left? There you go. How about the second two? I got to keep that minus sign. 1, because it doesn't have one, right? So because this is a minus in the middle, I changed the last sign. Now I have a common factor, which is 6x minus 5. What's left if I take that out? 2x minus 1. 29. Did you fix it? Do you see where you went wrong, more importantly? If you got a positive 3, then you should have, both of these should be the opposite sign. One set of your parentheses should have completely opposite signs. Like, if you took out positive 3, then you should have ended up with -6x plus 5, 2x minus 1, or 6x minus 5, -2x plus 1. So you just got 1. I bet you just dropped that negative sign off the front whenever you were supposed to have it. Because if I just take a 3 out, that first one's going to keep a -2. Okay. That's why it's better. Always take that negative out. When you, yeah. One of them's opposite. And if you ever get to that point in your factoring, stop and go, okay, something's not right, because if my parentheses are not exactly the same, then I did something wrong. Yes. Can you tell me what it is? I mean, I'll still do it for you if you'd like me to. I'll just jump on her. It's okay if you'd like me to do it. You sure? I don't mind working it for you. Yeah, let's finish the homework and then we'll take a break and we'll walk around. 27. Can you call out 27? Y'all haven't used your brain yet. Y'all are awful chit-chat today. Say it again. All right. Oh, we're crushing that juice, man. All right, GCF. 4. Somebody said 4. Somebody who's doing math said 4. 5x squared plus 31x plus 6. I need two things that multiply to what? 30x squared, but they add to 31x. What are they? 30 and 1, 30x and 1x. So I have 4 times 5x squared plus 30x plus 1x plus 6 slash. What's that SpongeBob, the something slasher? Y'all know what I'm talking about? What? Why? Is it inappropriate? It's not good for what? You don't actually have to factor the 4. So to address that, no, it will still group and you don't have to do it. But in order to be what we call completely factored, every GCM has to be out. So you have to do it in the very last step. You still need to pull it. Does that make sense? If you didn't GCF it first, now other methods you can't factor if you don't GCF it. But with grouping, if you don't GCF it and you factor it, that's fine. But then you should have a GCF of 4 in one of your factors that you have to take out in the end. Yeah. That's going to be first. You got 12 instead of what? You just copied it wrong. It's okay. It's okay. Okay. It's just effort. That's okay. Yeah. Slade, what you got? No, so that 20x plus 4, that binomial you need to take a 4 out of. Because factoring it completely will mean, when we'll get to that a little bit later, every single set of parentheses cannot be broken down any further. So since you can break that down a little bit further by taking the 4 out, you need to do that. But you can do it. Huh? No, that can't be broken down any further. Oh, yes, I'm sorry. Which is what we're going to end up getting here. If I take out a 5x, I end up with x plus 6. GCF is 1. You should come back to the same thing that we have. X plus 6, 5x. There's your 5x plus 1. Y'all got that? Can I scroll? Can you? Look. Yes. Yeah. 25. Yeah, let me do 23 and then I'll hit 25. Slade, give me 23. What was it? $16. GCF. Dose. Oh, this is a special one. What's left? 9. 18, 8. Oh, this is not special. Never mind. I thought I was going to get 4 on the end. All right, 72. What multiplies to 72? Z squared, but adds to 18Z. 6 and 12, 12 and 6. So I have 9Z squared plus 12Z plus 6Z plus 8 slash GCF of 9Z and 12Z, or 9Z squared and 12Z. 3Z, what's left? 4. GCF of the last two? 2. Leaves me with, if I get to this point and these are not exactly the same, I need to stop and reevaluate, go back up. Am I going too fast? Absolutely. It'll just be in a different order. Your factors at the end. 2. 3Z plus 4. Those are gone. It leaves me with 3Z plus 2. Yes, no, maybe so? Sure. You got that one? Yeah. It confused you. That's fine. It looks like it. That's why I do the line through mine like that. Yeah. All right, 24 and 25. Tell me what 24 is. Okay. You didn't have to do this one, but she asked about this one because it looks a little funky. And we're still going to talk about ones that look like this today. But what is the, I'm still going to do all the same process that I was doing before. What's the GCF here? 2. If I take the 2 out, what's left? What's missing? The BX, right? So if B is not there, what value does B have? Here's 0 and 1. Which one is it? Why? It's not there. I have to add it, and the only way to keep the value the same is to add a 0, right? If it's missing and you're multiplying, it's 1. If it's missing and you're adding, it's 0. All right, same process, first and last together. What multiplies to negative 16x squared but adds to 0x?
Negative 44.
Agree or disagree? It multiplies to negative 16, it adds to 0. As I set up my parentheses, what? What? First and last multiplied together. He's going to see it in a minute. Give him a second. There it is. Okay. All right. So I'm going to do the negative first because that's the habit that I'm in, because it's always easier if you have mixed signs to do the negative first. What's the GCF of the first two? 4 what? X. What's left? Middle sign. GCF of the last two? 1. Write this one down and keep it, because we'll use this as an example leading into today's lesson for us. 4x minus 1. What's left when I take that out? Nice. Notice how grouping still worked. Even though it looked funny, it still worked. What is he? Okay. Yep. Not vertex form. That's the standard form. No parentheses. Vertex and intercept have parentheses. There is, but in the original problem there wasn't. It was 32x squared minus 2. What'd you say, Emma? No? I don't think so. And I love math too. It's my favorite. No? Yeah, let me work 25 and I'll give you a break. We can't. Does it say that? What's 25? 6. Oh, this is a good one too. Minus 24u. What's the GCF? What's left? That is all I can do. I can do nothing else. Factoring out a GCF is your most basic form of factoring, and sometimes that's all you can do. Okay, y'all have been super chit-chatty, so hopefully let's take a break. That wasn't even in the number. Oh, okay, yeah, I will though. I will. What's 26? Give me the from. 12 what? Say it again. All right. If I can reel you back in here, boys and girls, gals, and GCF. 3. What's left? 27 is not divisible by 4, y'all. Oh. Okay. Just tell me to shut up. Okay. 36m squared. What multiplies to 36m squared but adds to 12m? This is a special one, and this is also going to lead into the lesson today.
93.
Good job. Agree or disagree? Does negative 6 times negative 6 equal 36? Does negative 6 plus negative 6 equal negative 12? Yes. So in fact, these factors are the same. So I have 4m squared minus 6m minus 6m plus 9. Write this one down too, because this is a great one. We'll just start with this pattern instead of the other pattern I was going to start with. Since I'm working this one now. If I slash this one in half, I have 3 times, what's the GCF? 2m. What's left? The middle sign stays. That's exactly. Watch. 2m minus 3. When I take that out. What in the world is going on here? It's the same thing. As according to Miguel. So this is 2m minus 3 squared. This is a special pattern that while right now you don't have to be able to recognize it, and this is where transitioning it. Oh my goodness. Transitioning into notes now. So we'll use this one to we'll piggyback on here to pick up the notes. But we're going to talk about 2 special patterns, and then we're going to talk about factoring and solving. This is a special pattern. You don't have to know it just yet, but by the time we get to maybe 3 or 4 lessons in the future, you will have to be able to recognize it. So you might as well go ahead and learn it now. But this is what we call, Factoring special patterns and solving. This is called a perfect square trinomial. It's the hardest. Have y'all heard of this before? No. Okay, it's the hardest one to wrap your. All right, guys, if I can have your attention, please. It's the hardest one to wrap your brain around because of what it does. You can factor it by grouping like we did here, but there's a shortcut here, okay? Now, here's what. It has to meet 3 requirements. Are y'all ready? To be a perfect square trinomial. Yeah, this is new. This is new. This is called factoring special patterns and solving. We're doing it all. What time does the bell ring? I have 20 minutes. We got plenty of time. Solving. Okay. All right. This is the hardest part of the lesson today, and we're going to start with it, so it'll all be downhill from here. Yeah. All right, 3 things that make something a perfect square trinomial. Now, you know what perfect square means, yes? Tell me what it means. Multiplied by itself, right? I can take the square root of the number. Yes, absolutely. So I'm using this to springboard our lesson for today. Problem the whole problem. Okay, I'll give y'all a second. Yes. Patterns. There you go. Start of the lesson today. Yes, that is a perfect square trinomial. And so we're going to talk about what it means. I'll give you a second. Just the 4n squared minus 12n is the perfect square trinomial. Yeah. Well, I mean, it's your notes, so you can put whatever in your notes you need. Yes, yes. Because remember, if the middle sign's ever negative, it changes the last sign. We factored a perfect square trinomial. Today's lesson is about recognizing a perfect square trinomial and factoring the shortcut. Yeah. When in doubt, write it. I'm gonna let everybody catch up with me so that they're not frantically writing while I'm. Well, so you can do that too, and then you have the notes on Mirrorboard. You got to link to them every day. I do better when I write it down, so I remember. I remember better when I write it. I like stress out on it. All right. 9. Perfect square. Yes. Perfect. Who are we waiting on? All right, perfect square trinomial. We said what perfect square was. We know what trinomial is. Do we know what trinomial is? What does tri mean? 3 terms. 1, 2, 3. Yes. All right. Here are the qualifications to be a perfect square trinomial. Three terms. Yes. Y'all good? All right. That's not actually one of the qualifications I was talking about, but okay. The ends must be perfect squares. That's your first qualification. The second sign, this one must be a plus. That's your second qualification.
Wait, perfect squares, those are ones that two numbers are the same.
Huh?
It could be like, wait, I know what it is, but I don't know how to give me a lot.
Say it again.
Perfect square, what's the definition of that? Like, I know what numbers are perfect squares.
You can multiply something by itself. Like the ends here must be perfect squares. So if you look at this one, 4m squared is a perfect square. 9 is a perfect square. Not always. All right. Oh, maybe.
Wait, what was the second one?
That's a good question. 25 times 4 is 100. That's a perfect square. 9 times 25. That's a perfect square. It might be on something. I've never thought about it. Is the product of perfect squares always one? No. Find one that's not. Find a counterexample and disprove it. Okay. That's a geometry thing. Find a counterexample and that disproves the theory of. Okay. The ends are perfect squares. The second sign is a plus. Notice I did not say anything at all about the first sign because that doesn't matter.
Oh, I found one.
The middle. What?
9 and 9.
9 times 9 is 81. 81 is a perfect square. Okay. The answer is yes. Good job. Thank you. Nice. That was nice. That was a great conjecture, and now you have proof. Okay. The middle term. Here's where it confuses everybody. This middle term must square dance. Now, what do I mean by that? I'm definitely not getting up here and do-si-doing or anything. But it must do the square dance, and here's what that means. If you take, let's call this a squared, and let's call this b squared. Okay? This middle value, if you take the square root of the first one, what's the square root of a squared? A. You take the square root of the first and the square root of the last. What's the square root of b squared?
So it must be more like.
It has to be, wait a minute. It must be double the product of the square roots of the ends. So I said square dance because here's what, this is how I remember it. You go square, square, multiply, and double. Can y'all do that? Square, square, multiply, and double.
Okay, I'm sorry, can you just explain that?
Yep.
That doesn't work. Because with that, 9 is 3, and then 4 is 2 plus 3 is 5.
No, product. Product, not sum.
Oh, all right.
Huh? It could be a plus or a minus. It's not one of those requirements. Ends are perfect squares. Second sign is plus, and it has to switch. Okay, you don't understand which part. The third rule, the square dance rule. All right, we'll get up and start dancing now. Okay. Square root would be a. Square root would be a. They do. So the square root a times b multiplied together and double. Look at the example this here. What's the square root of 4m? the 2m. What's the square root of 9? So what's 2m times 3? Double. 12m. That's what's in the middle. So that is a perfect square triangle.
You're doing some crazy numbers, but we gotta figure out.
I think that there's a better equation.
Yeah.
I'm trying to find an equation for the square dance.
Multiply.
I found an equation for the square dance.
I'll post it. I'm not sure yet about that. All right.
The square root of the first, the last
Hold on, Miguel. Hold on.
multiply together and double.
Yep. Square, square, multiply, and double. Y'all don't make me dance because I can't do that well either. No. I don't have a dance made up for it.
I don't know.
Okay, so.
I don't know what to do.
You'll be scarred for life. Okay. So, if that's true, now we say all that yet. I did too. It's 2AB. Okay, if that's true, right? If this happens, we do all that just to recognize it being a perfect square. If that's true, it's an easy factor. It factors as the square root of the first one, whatever this first sign is, whether it's plus or minus, the square root of the last, and then we just throw a squared on it. So you might say, that is entirely too much to remember. I'd rather just group it because I just mastered grouping. I know how to do that and it always works. But we're going to get into some rather large values that if you can recognize perfect square trinomial now, it will save you an immense amount of time and heartache. Yes. You can't put this in a calculator. So look, 4m squared minus 12m plus 9. We said yes, it's a perfect square trinomial, so it should be the square roots of the ends, the first sign squared. Is that what happened? It's a shortcut. It's a special pattern. It's a very, very, very important special pattern, but it's a special pattern that you'll have to know later for sure. Yes, that's what I'm saying. It eliminates all that work for you. Like I thought. Let me give you a couple. You tell me perfect square trinomial or nah. Oh my goodness. What last thing? That's what it looks like to start with. But the ends are perfect squares. It's just in variable form is all it is. The ends are perfect squares. The second sign is a plus, and then the middle is the product of the square roots of the ends doubled. Okay, look at these. Yes. That's not the one we just did, is it? Oh my gosh, what is wrong with me? Wait a minute. Uh-oh. Look at the first one. It is not. It meets requirements 1 and 2, but it does not dance.
It would have to be 20.
Dance.
It has
2 times 5 is. They forgot to double. Square multiplying double. Not a perfect. What would make it a perfect square trinomial? if that was a 20 instead of a 10. And what would it look like factored? 2x plus the hardest part is checking it. The hardest part is confirming that it's a perfect square triangle. What is the square root of 4x squared? What's the square root of 25? If you multiply those together, you get 10x, but you also have to double it. The ends of the middle sign. After you take the square root, yeah. Square root. Yeah. But it only works if it meets those three criteria. If it doesn't meet those three criteria, you can't do that. So if that had stayed 10, that would have been a CDF problem. Somebody else has, yeah. That's correct. That's factored. If you group this together, so if you multiplied 4x squared to 25, you get 100x squared. And then you said, well, what multiplies to 100x squared but adds to 20x? 10x and 10x. If you filled that in, you grouped it, you slashed it, you factored it, this is what you come back to. This is just a shortcut for factoring. But your numbers can get really big really fast, especially whenever you start getting into maybe 144 or 225 and things like that, then you're trying to find the factors that work, it gets hard.
You can't factor it.
Correct. The CDF. How about the second one? No, it is not a PST. Why is it not a PST? That last negative sign. If that was a positive. So if I did that, yay or nay? How does it vote? I heard no and I heard yes. It does though. 5 times 2 is doubled is 20. How does it? No!